Okay, guys, let's take a look in our Algebra 2 packet on Lesson 80. We're going to be talking about direct variation as a ratio and inverse variation as a ratio. I'm going to get another sheet of paper here because I want to do just a few notes with you before we actually get started here. Okay. Let's do a little bit of memory recall here first. All right, so we've learned that when a problem states something like this, variable x varies directly, right? And those are key words. Whoops, directly, I'm not even spelling it right. Directly, here we go. As variable y. And we've done some of these problems. So variable x varies directly as variable y. Okay, we know that this is a relationship that looks like this. X is equal to a constant of proportionality, which we call k, times y. And by the way, that k being a constant of proportionality, if you think about it, all that really means is what is the, if you have ratios set equal to each other, you think about a proportion, right? You have two ratios set equal to each other or equal fractions, any of those kinds of things. For example, you know that this was multiplied by 2, right? It increased by 2. So the proportion, 1/2 equals 2/4. The constant of proportionality in there is the scale factor. We've also heard it called that. So I don't want you to be too confused over such a big name, but that's all that the constant k is. And in these types of problems, what we learned is that we always solve for k first. Once we solve for k, then we complete the rest of the problem to find out whatever's missing. Now we're going to look at an example here. And we're going to say that this is actually one in your book. It's 80.1, so I'll go ahead and write what that is. And let me just write out what it says here. A varies directly, I'll try to write quickly, as B. If A is 50, when B is 5, what is the value of A when B is 7? Okay, so we're going to use, instead of X and Y, we're going to use A and B, and we've been doing that. So we notice this is a varying directly problem here. So if we use this little equation up here, we would say that A varies directly with B, and we put that constant of proportionality in there. Then we fill in A as it is in the beginning, and we put in B right here. We would divide both sides by 5, right? And that's going to tell us what our constant of proportionality is, what k is equal to. So if k is equal to 10, now I can go, so the next thing we would do here is we're going to take A, and we're going to fill in 10 for k times B. Okay, now let's fill in what we have. Remember, we're looking for what is the value of A. So A is going to be our isolated variable that we're solving for here. We're going to put in B. B is 7. And A then would be 70, which makes completely good sense because if K is 10, that's your scale factor, right? That's the constant of proportionality that tells you how the proportion has increased, how the second ratio got larger or smaller. And in this case, it was getting larger times 10. So the answer is actually A is equal to 70 because that's the question that they asked. Now we're going to learn another way of actually writing this. And many mathematicians and scientists actually use one or the other or both. So another way to work the same problem is that you could set up an actual proportion where you put your first A in A1, your second A in A2, your first B in B1, and your second B in B2. So let's look and see how this would work out using the problem above, 80.1, where A varies directly as B. And if A is 50 when B is 5, what is the value of A when B is 7? So let's think about this. So the beginning A value is the A1. So I'm just going to put an arrow here so you can see what I'm filling in. So A sub 1 actually is our starting A value, which is 50. We're looking for what A is in the end, right? So that's going to be our variable that we're going to try to solve for. Our B sub 1 is what our beginning B value is, which we were told up here is 5. So we're going to fill that in for B sub 1. And then in the end, B was 7. So here we have this beautiful proportion that we can actually solve. And watch how this would work then. So we'd have 5 times A sub 2 equals 7 times 50, which would be 350. We can divide both sides by 5 to isolate the variable, and A sub 2 would equal 70. And that's exactly the same answer that we got above right here. Okay, it's just another way of doing it. And quite frankly, I actually like this way better. But, you know, like I said, some mathematicians and scientists use the first method and some use the second method. But today we're going to be practicing using the second method. So what I want you to write in your packets now, this is going to be your part. Right up here where it says direct variation, I want you to notice, I want you just to kind of look up here. This is where you have, this is what we learned a while back, and today we're learning this one here. Okay? Now let's do example 1. Example 1 says, apples vary directly with bananas. If there are 6 apples when there are 18 bananas, how many apples are there with 30 bananas? Okay, so we have been using the equation that would look like this. We would use A equals our constant of proportionality times B. Okay, we would solve for K, and then we go back and we plug K in, and then we can figure out whatever we need to solve for. In this case, how many apples there will be when there's 30 bananas. But using today's new method, let's write out how this is going to look. So if it's apples to bananas, we really are using A sub 1 and A sub 2 and B sub 1 for bananas and B sub 2. Where the A sub 1 is our beginning apple number, which we see there's 6 apples in the beginning. In the end, we're trying to find how many apples, so that's going to be our missing variable there. We're going to put a variable or our missing unknown. The first count of bananas is 18, and in the end, we had 30. So here's what we're solving. So let's go ahead and do that. So I'm just going to put little arrows here so you can follow my trail. So we do 18, we do our cross products here, right? We just multiply cross products, equals 6 times 30, which is going to be 180. And if you solve this to the end, you're going to have 10. So there are 10 apples when you have 30 bananas. Okay, now let's talk about varying inversely. Whoops, what happened here? Oh dear. There we go. Okay, I'm going to go back down to my little notepad. I'm going to write in blue, and I'm actually going to get one more sheet of paper in case I need it. Change my pencil color. All right, so the second part of this now is when we're varying inversely. So if A varies inversely, remember we always have to pay attention to that, whether it's directly or inversely. So in this case, if A varies inversely as B, we have learned that to solve for that, we still want to solve for the constant of proportionality, and K represents that. Okay, but we're dividing this now because it's an inverse operation of multiplication. Okay, because remember the first set up here, the first equation was to multiply right up here. Okay, think about that. Inverse operations are always opposite operations. So in this case, we're dividing here. Okay, so how would I use my new concept here? We're going to write something different here. So if A varies inversely as B, we're going to write an inverted ratio. So let's write the first part. It's going to be the same. What's your beginning A? What's your end A? But here's where we're going to do our flip. We're going to do an inverted ratio. So instead of B1 over B2 here, it's going to be B2 over B1, which is opposite of what we had right up here. Okay, so it flips. It's the inverse of that original one. All right, so let's look at our, and actually if you'll notice up here in your packet, right here, this was what we have been using for inverse variation. Today, it's going to be this, where the difference between this one up here and this one down here is just the second ratio is flipped. It's the inverse. Okay, now let's look at example 2 here in our packet. So cats vary inversely with birds squared. So I want you to think about that. So what this really is going to be is birds squared. Okay, so that's going to be in our equation. Okay, if there are 9 cats when there are 8 birds, how many birds are there with 16 cats? Okay, so we're starting with 9 cats and 8 birds. We want to figure out how many birds there are with 16 cats. Now remember, what we've been using is our old way, where we would take cats very inversely. So we would write it this way with our constant of proportionality, which is K over B. That's our old way. But our new way is going to look like this. So we're going to use C for cats. So we have cats in the beginning, cats in the end, equals birds in the end. Remember, we're going to actually use the inverse of this. So you flip that ratio, but it's B, all the birds are squared. That's what it says right up here. Birds squared. So we're going to have to actually square those in this case. Okay, so let's go ahead and figure this out. So cats in the beginning is 9. Cats in the end is 16. We're trying to find how many birds there are in the end, so that will be the second one with a little sub 2. And we're going to square that. And birds in the beginning were 8, and it's squared, because that's what it says on the problem, remember? All right, let's do our cross products over here. We're going to have, excuse me, 9 times 64. Right, if I do this, 8 squared is 64, so 9 times 64 equals 16, b sub 2 squared. Let's go ahead and figure this out. So 9 times 64 is 576 equals 16 b squared squared. We're going to divide by 16. We're going to end up with b squared squared equals 36. We have to undo this to get rid of the square by using the square root sign, and we end up with b sub 2 equals 6. So in the end, you would have 6 birds. So in the beginning, you have 9 cats and 8 birds, and then in the end, you have 16 cats and 6 birds. All right? Okay, next. Let's go ahead and do practice A and B together. Now be careful when you read these. I actually made the assumption that the first one was going to be varying directly and the second one was going to be inversely. However, they're both varying inversely, so I struggled with why I wasn't getting the right answer. And it's simply because I didn't read it right to start with. So please always make sure, don't follow that mistake I made, and try to read those carefully. So letter A says cost varies inversely as the number purchased. If 15 can be purchased for $225, how much would 42 cost? All right, so Our varying here is cost and purchase. So we are going to set this up as the original cost and what the ending cost is going to be. And since we're varying inversely here, then our second ratio is going to actually be flipped. So purchased, the end one here, and then the beginning one here. All right, so and then we just fill in what we have. So the beginning cost is $225. The end cost is what we are looking to solve for. The purchase is 42. The number that our purchase is 42, and that's in the end, and then the beginning purchase was 15. All right, now you can just do your cross products here. 42 C sub 2 equals 225 times 15, which, by the way, is 33.75. Let's divide both sides by 42. And the nice thing is it will work out nice and evenly. Well, actually, I think when I did that, I think you actually did have to round. But if you put that in your calculator, it's going to be $80.36 when you round it. Okay, so in the end, the cost would be $80.36. Now let's look at letter B. So blues vary inversely as yellows squared. So this one's also inversely. Okay, varying inversely. So we know we're going to flip that second ratio around, right? So blues vary inversely as yellows squared. Okay, so our yellows are going to be squared, right? So we're going to raise that to the second power. If 50 blues go with 5 yellows, how many blues go with 10 yellows? Use the equal ratio method to work the problem. Alrighty, so we're going to have our blues, B1 and B2. And on the other side, we're going to flip it. So it's going to be Y yellows. Whoops, let me make that a capital. Yellows, yellows 2, but then it's going to be raised to the second power. And yellow 1 is going to be raised to the second power. Okay, let's fill that in. Let's go back to the problem. Blues vary inversely. Okay, 50 blues go with 5 yellows. 50 blues go with 5 yellows. Oops, I'm looking at the wrong one. Sorry. Oh, goodness, when I do these late at night, it doesn't always go so well. All right, 100 blues go with 3 yellows. Sorry about that, guys. Letter B, 100 blues go with 3 yellows. So 100 blues, that's our first one, B sub 1, goes with yellow. So that's going to be our first yellow, and our first yellow is going to be this one because it's the first one. B sub 1 is 3, and don't forget, it's squared. How many blues go with 10 yellows? So we have 10 yellows squared over B sub 2. And that's what we're trying to find, is how many blues. So in the end, the B sub 2. All right, so let's do our cross products here. So 10 squared is going to be 100. B squared, or excuse me, B sub 2. And then 100 times 9 here, right? 100 times 9, I go ahead and write that out. 100 B sub 2 equals 900. Divide both sides by 100. And B sub 2, the number of blues in the end, is going to be 9 blues. Okay, and that is how you work using that new method. And I hope you like that one. I actually kind of like this one a little bit better than I do the other one. All right, guys, go ahead and work on the lesson. Have fun with it, and we will catch up later.